I'm Victoria Casares, and I'm going to explain the historical development of chemistry as a science. The history of chemistry represents a time span from the ancient history to the present. By 1000th century, civilization used technologies that will eventually help us form the basis of the various branches of chemistry. Examples include the discovery of fire, extracting metals from ores, making pottery and glasses, fermenting beer and wine, extracting chemicals from plants for medicines and perfumes, and etc. The goal was not to understand the physical world. That came later. People just wanted to do things that will improve their lives in a better way. Proto-science of chemistry, alchemy, was unsuccessful in explaining the nature of matter and its transformations. By performing experiments and recording the results, alchemy set the stage for modern chemistry. Took its present scientific form in the 18th century, when careful quantitative experiments by Lavoisier, Proust, and Dalton result in the law of properties of matter, the law of conservation of mass, the law of multiple proportions, which laid the groundwork for Dalton's atomic theory of matter.
Hi, my name is Yaskara Renee Solis Rodriguez, and I'm going to be talking about the chemistry and its relationship with other sciences. It is known that chemistry is a multidisciplinary science. That's why it has a lot of relationship with other sciences, such as physics, mathematics, engineering, and more. In relationship with physics, it is known that chemistry and physics both study matter and energy. That's why physics applies concepts to chemical systems or processes. In relationship with biology, chemistry finds the substances that make up organisms and the chemical compounds that are involved. Now, with medicine, it focuses on creating and understanding drugs for treatment of disease. In geology, it studies the Earth's chemical composition and processes. Chemistry is also involved in agriculture, in the use of chemicals to improve crop growth and soil health. Now, with engineering, chemistry is involved in the research and production of materials such as steel and glass that make up constructions. And now with math. Math helps with the equations and calculations that explain the behavior of matter.
Matter can be classified into pure substances that have a finite composition and into mixtures that contain two or more different substances that are physically mixed but not chemically combined. Also, the portions in mixtures may change and they can be separated using physical methods. Talking about pure substances, we can find elements and compounds. Elements are composed of one type of atom and they cannot be separated into simple substances by physical or chemical means. Now, the compounds are composed of two or more elements and they are always combined in the same proportion. They can be broken into simple substances by chemical means. Talking about mixtures, we can find homogeneous mixtures that have a uniform composition. That means that the different parts of this mixture are not visible. And homogeneous mixtures are also called solutions. Now, talking about the other type of mixture, we have the heterogeneous mixture, that its composition varies from one part of the mixture to another one, and the different parts of this mixture are visible. They can be colloid, suspension, and other types.
As my teammate said, matter classification is divided into pure substances and mixtures. And we know that the pure substances cannot be broken down or separated into new products, but mixtures can be separated using different separation methods since they are combined physically. Heterogeneous mixtures are easier to separate by simple means, like for example filtration or sieving, which consists on separating the mixture through a barrier with holes or pores, or hand picking using your own hands, and with decantation using a funnel to separate a liquid from a solid or liquid below. With homogeneous mixtures, there's distillation or fractional distillation, which consists on heating the substance to separate it by the difference of boiling points. Centrifugation used to separate solid particles from a liquid with rotation speed, and evaporation, which separates substances in dissolved solids.
and I will be explaining to you the properties of matter. When we are speaking about properties, we are speaking about the characteristics that matter can have. These properties can be either physical or chemical. In the physical properties, we have general properties that give us information about how substances behave. For example, we have mass, inertia, porosity, etc. We also have specific properties that, these are characteristics that can be seen. For example, smell, flavor, physical state, density, malleability, fragility, and so on and so on. On the other side, we have chemical properties. These give us information about how matter has the ability to create a new substance when coming in contact with other substances. An example of a chemical property would be the ability of silver to tarnish, or a paper to burn when coming in contact with fire, for example.
Hi, my name is Carla Valeria Lopez Hernandez, and today I'm going to talk about the change in matter, also known as physical changes. So basically, these changes do not involve an alteration in the internal structure of a substance. That means that only the shape is affected. So changes in the state of aggregation of matter are also considered physical change. So now we are seeing in this image the different states in matter and their aggregations. We can see the basic states that are solid, liquid, and gas. I'm going to explain briefly this diagram. Basically, we are seeing that solid to gas is sublimation, then gas to solid deposition, then gas to liquid condensation, liquid to gas evaporation, and finally we have liquid to solid freezing, and solid to liquid melting. So this is the states and their aggregation of matter.